So just with this last video, what we're going to do is show you spots where you can practice these laws. Okay, these questions on their own really aren't very practical, so we just have to be good at the laws so we can use them in the next upcoming lessons. So the questions on their own really don't have a purpose other than a spot for you to practice the laws. So you need to take that into account when we're doing these. So what we do is we ask you to use these laws of logarithms to take some big expression and express it into a single logarithm. Now, it might actually make our life easier. Instead of having to evaluate a whole bunch of logarithms, we might be able to simplify it into a single one, and maybe the evaluation will be a little bit easier. So I don't want you to go off and try and evaluate them separately. The point of this is to practice bringing them together and then evaluate at the end, if it's possible. So we're going to go through and use some of the laws. So the first thing you're going to notice is, well, there's not much I can do with the first. It's just log 2 base 8. And then plus, if I had to try and figure out what exponent do I put on 8 to get a 2, that doesn't look too easy. The second thing I'm going to notice is I have a 3 times a log. So the power law tells me I can take that 3 and bring it up as an exponent. And then I can do the same thing in this last one. This 1/2 is being multiplied, so I can bring it up as an exponent. Now, why would I do that? Well, it might make the actual logarithm a little bit easier. So nothing on the first one. But this is now 2 cubed. So let's actually figure out what 2 cubed is. 2 cubed is 2 times 2 times 2, which is 8. So already I'm seeing, hey, this might make that question a little bit easier. The last one is 16 to the 1/2. Remember, 16 to the 1/2, that's the same as the square root of 16. All right. So that's log 8, and the square root of 16 is 4. So already, if you look at the first line and you compare it to this line, we've made things a little bit easier. And in fact, one of the logs is really easy, this middle one. But I'm not going to evaluate it yet. I'm going to now combine them even more, because that's what it says. Express as a single logarithm, then go off and evaluate if it's possible. So here I have 3 logarithms. The unique characteristic of each of these logarithms is that they have the same base. Base 8, base 8, base 8. And I am adding them. So I have a law that says when I'm adding logarithms with the same base, I can combine them into a single log and do what to the answers? Multiply them. So I'm going to express this as a single log, and since I'm adding each of them, I can multiply the answers. So it ends up being 2 times 8 times 4. Sorry, what's that? 64. Thank you to the awesome in-studio audience here for their participation. Not yet, not yet. No. And now, is this an easy logarithm to evaluate? I've expressed as a single logarithm. This says, what exponent do I put on 8 to get 64? Everybody tells me it's... Oh, you got to be loud so you're on the mic. Okay, I'll try this again. What exponent do you put on 8 to get 64?
2!
Awesome. What an amazing class. Best class ever. Better than the class that is actually watching this video right now, right? Yeah. Oh, wait, I just insulted the people who are, yeah. That's going to be awkward. Okay. Unless I'm not this class and it's not me, and yeah, this is going to be a great video. Okay. So we can see how the reason we do this, again, it gave us opportunities to practice the laws of logarithms. That's the point of this question. So we're going to do it again in B, and I'll ask the supply teacher to maybe pause here and give the students an opportunity to try this one on their own. Okay, so now that you've had a chance to try this on your own, we're going to ask our guest lecturer to answer this. So here's Mr. Wallace.
Hey guys, hopefully I get this right. So we started off by seeing that this one's 2 log 8, so we can put that 2 onto the 8 as an exponent, and then these ones can just stay normal over here. Log 9 minus log the 36, and these all have the base of 10 because there's nothing there. Put that there. And so you would go 8 to the power of 2, which is 64. And then these ones, again, stay normal. And so now you can put these all together. It's the quotient law, I think, but I don't know. Log, and you put them together. So this one's adding, so it's 64 times 9, and then this one's subtraction, so it's division over 36. And so you can, I'll just do this one step at a time. So 64 times 9 is, what was it again? 576, okay, over 36. Then that equals, it turns out to be 16. And the log of that, yep, so base 10, what exponent do you put on 10 to get 16? And it's 1.2041. 1.2041. Yep. And that's how you do it. Thank you for having me. Bye.
Is this where we're going to applaud? Yeah. All right, thank you, Mr. Wallace. So I think that's about the size of it. So again, these questions are here for you to practice the laws. So when you're looking at your homework, I want you to just use these as a way to practice the laws to evaluate. So here's some practice questions. Again, there's I don't expect you to do all of them. Maybe A and C or E from each. Notice that 3B is incorrect if you choose to do that one. And then you can go from there. So this lesson was recorded in front of a live studio audience, best class in the world, and they just wanted to come and say hi. So that class, this class is made up of
Jake, Erica,
Dalton,
Chris Wallace,
Dustin,
Carmen,
Wyatt McCann,
David Willman,
Jeremy Emsley,
Jacob, Brian.
That's right, El Presidente was with us today. That's awesome. All right, thanks a lot.